All right, I'm going to do a tutorial video on calculations for week 3. And so this information that I have here comes from your week 3 resources, but I do want to explain it a bit, and hopefully this will be helpful for you to understand what's going on with calculations. First of all, we have the balanced equation, and in the previous portion, it talks about balancing equations. So I'm not going to go through that. But we have 4 KO2 solid plus 2 CO2 gas, and the arrow produces 2K2CO3 solid plus 3O2 gas. And it says how many grams of KO2 are required to completely react with 0.400 moles of CO2. And so there are 2 steps in order to solve this problem. You can do it in one step, but sometimes it's easier to see the problem broken down into 2. So let's go through that. So we first want to determine how many moles of KO2 are required. And so we start off with our 0.400 moles of CO2. That's what's given here in the problem. And then you're going to multiply this by a conversion factor. In your conversion factor, these numbers come from your balanced chemical equation. They are the coefficients that are in your balanced chemical equation. And so for CKO2, you see it has a coefficient of 4. For CO2, it has a coefficient of 2. Since those are the only 2 substances that we are looking at for this portion of the problem, that's all we have to worry about. We don't have to worry about the rest of the equation. And so you're going to start off with, let me get my arrow back. You're going to start off with the 0.400 moles of CO2. We're going to multiply. And then we want to put our desired substance on top. What substance we start with always goes on the bottom. And so 4 moles of KO2, remember we got that from our coefficient, divided by 2 moles of CO2, again, from our coefficient. And so we're going to multiply everything that's on the top, divide what's on the bottom, and you're going to get 0.800 moles of KO2. So that's our first step. But we don't want moles of KO2 for our answer. We want the grams. So we're going to go to our next step. And now we want to know how many grams of KO2 are required. So according to the periodic table, we can use the mass of potassium plus 2 times the mass of oxygen in order to get the molar mass. Okay, so our potassium, just to give you a heads up of how we got that value. So our potassium, according to the periodic table, see if I can write this correctly. Let's see if I do it better with my finger. There we go. My mouse was not wanting to write for me. All right, so potassium's 39.10, and that's grams per mole. I just ran out of room here. And then oxygen, we have 2 of them. So we have 2, woohoo, 2 times, and oxygen is 16.00 if we round that number that's given in the periodic table. It's depending on what periodic table you have. Sometimes it's already rounded. Okay. Kind of hang it over the side, but you get it. All right, so if we take 2 times 16 and we add it to 39.1, that's where we get that 71.10 that is given here in this problem. Okay. All right. My camera is there, so it's not wanting to do that. All right. But anyway, you get where that comes from. All right. Oh, my screen went crazy there. Okay. I don't know what happened to the coloring on my screen, but it's not important. It's important that you see this and not necessarily me. All right. So when we are doing this setup for this last step. We start off with the moles that we were given from the first step. Now we want to get rid of the moles and we want to go to grams. And so to do that, we have our grams at the top from our molar mass and then 1 mole at the bottom. When you're doing the molar mass, the number that you calculate that's shown here always goes with grams, one always goes with the mole. So even if the grams had to go to the bottom, you still would have 71.10 grams. It would be at the bottom, all right? But you want the grams at the top because that's what we're looking for. We multiply the things that are on top, you divide by what's on the bottom, but we just have a 1 there, so if you divide by 1, it's still the same. So we get 56.9 grams of KO2. Hopefully this is helpful as you're going through your calculations.